Good afternoon and welcome to Webinar Wednesday. Today we are joined by Ted Lucidi, Director of Commercial Operations at Innovatus Imaging. Webinar Wednesday would like to thank our sponsor, Innovatus Imaging. It is the ISO 13485 2016 certified preferred provider for best-in-class repair services for medical imaging products. The company's expertise spans the entire device life cycle from design, development, manufacturing to sales, distribution and repair. With a legacy spanning over 30 years and having repaired more than 175,000 ultrasound probes and 40,000 plus MRI coils, the company has accumulated tremendous amounts of data, which serves as a massive knowledge base for continual improvement. The company operates an FDA-registered site for the design and manufacturing of ultrasound transducers and related products. Headquartered in Pittsburgh, Innovatus Imaging also maintains centers of excellence in Tulsa, Oklahoma, and Denver, Colorado. For more information, visit innovatusimaging.com. Just a quick reminder that MD Expo is headed to Temecula Valley's Pechanga Casino and Resort next month, October the 11th to 13th. Registration is open online at mdexposhow.com and you can use VIP code 22MDESOCAL at checkout to receive complimentary admission to this 3-day conference. The VIP code is available to individuals employed with a hospital, healthcare facility, or active military or students. Okay, today's webinar is eligible for 1 CE credit from the ACI. You can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit, and you will be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. We'll wrap up today's presentation with a live Q&A, so please submit your questions anytime using the questions feature on the webinar dashboard. So let's kick off today's webinar by giving away one of our brand new Webinar Wednesday t-shirts to the attendee that can tell me the answer to the following trivia question. As mentioned before, our sponsor today, Innovatus Imaging, is headquartered in Pennsylvania. So which city is considered the chocolate capital of the US? Answer now using the questions feature on your dashboard, and I'll reveal the answer at the end of the webinar. As I mentioned earlier, Ted Lucidi at Innovatus Imaging is our presenter today, and he will discuss MRI coils, failure analysis and strategies to minimize support costs. Ted, you may begin whenever you're ready.
All right. I couldn't have said it better myself, Linda, and thanks so much for the kind introduction. We are greatly looking forward to MD Expo. It's always a great turnout and a great opportunity to share great information with the HTM community. And so thanks for the introduction. I am Ted Lucidi. I'm Director of Commercial Operations. And with me today behind the scenes is Nate Barzakowski and Brian Espy. Nate's our Director of Operations in our Center of Excellence for MRI coil repair. And Brian Espy is our lead R&D engineer as well. Wanted to have them here in case any of you had any specific questions regarding coil design, coil failures, what you guys see. And so they are here now, but they'll be here at the end as well to address any specific questions you guys might have. I am going to dim my webcam so we can focus on the webinar, because you guys don't want to see me, you want to see the content. So let's just jump into this thing. So, a little bit about Innovatus Imaging. If you haven't worked with us prior to this webinar, if this is your first encounter with us, besides MRI coil repair, we also perform ultrasound probe repair. We have manufacturing experience with both of these product lines. We were once a coil manufacturer, but also we do have an FDA registered facility for manufacturing ultrasound probes. But we've been doing MRI coil repairs as well as probe repairs since the mid-1980s. One of the pioneers in both of these industries. We do perform repairs and restorations for several large OEMs. I can't tell you their names, but if you have MRIs, you probably know who these guys are. They are some of the most prevalent in the industry. I just can't say them by name. You can see some of our statistics down there. I don't think anyone can say that they've repaired more than 40,000 coils, as well as 170,000 ultrasound probe repairs. And a lot of this content from this presentation has come directly out of our business system, where we do track and trend all of this failure analysis data, because we do retain full device service histories on every device that we service. And we can get to that data. If we've worked on it, we can get you that data if you want that level of detail. Right, so what we're going to go over today is we're going to do a microsecond overview of coils. If you've never encountered an MRI coil before, talk about how we did this failure analysis methodology. We have, over the last couple years, we've actually 18 months, we've done 3,600 coil repairs. So we're going to look at the failure analysis and root cause data from our top 10 models. And then you're going to see how that translates into all of the other coil models that we've worked on. And then finally, the meat and potatoes of this whole session is really to talk about some strategies to minimize your pain points that you experience. And so your budgets go a lot stronger, a lot longer, and a lot stronger for you guys in the end. So if we look at why coils work, or how coils work, in essence, they are just an antenna. They amplify some minute signals that are given off from your body. And you know, a little analogy here, your body is like a news broadcaster standing out in the field, broadcasting the hurricane right now on the Weather Channel. We beam that information and then project it onto your home TV screens. Well, in the MRI world, you are the broadcaster. The coil is the antenna that picks up these signals, and then we just display them on the display for the radiologist to review. So in a nutshell, you know, that's how a coil works, or that's what a coil does. For the best image quality, the coils need to be as close to the anatomy as possible. The same thing is true as in the ultrasound world. You get your highest quality images from being as close to the region of interest that you're trying to image. So a couple, you know, there are over 1,000 makes and models of coils currently in use, you know, based on the OEMs, the scanner platforms, maybe even the software level and the anatomy you're trying to image. So there's just a short list of the variety of coils that exist in the world. In general, coils are divided into 3 main categories. So we have solid coils, they're hard plastic. And depending on the coil category, you're going to see that relates into the modes of failure that do exist and the types of failures that do occur in your environment. Looking at a coil on the inside, a pretty complex network of components and traces in there. Most of the coils that you see that I'm showing here are what I call multi-piece coils. Different assemblies will snap on or detach to allow access to different parts of the anatomy. A flex coil is designed to do just that, flex around different regions of interest, whether it's a coil that is draped across an entire body like your chest or your legs, or something that can be wrapped around a piece of anatomy, such as the air coil that I'm showing you on the right-hand side there. That's designed so it could be actually wrapped around a piece of anatomy. And then take another look inside of a flex coil. All of the components, all the amplifiers, all the discrete components are mounted to flexible circuitry that can be bent, dare I say, twisted, as it's wrapped around the anatomy. And then finally, we have some hybrid systems that are modular in nature. So we combine flex coils integral to the solid coils that make a whole suite of coils for the magnet itself. All of these interconnect or can interconnect with each other. and failures in one component might be related to or affect performance in another area of a different part of the coil suite. Inside of a coil, we have both passive and active components. The components might be surface mounted, or they might be the discrete components that we're all familiar with. Some of the values of capacitors and inductors, or some of those components, are actually variable depending on the design of a coil. So some of them might allow tuning to occur. But in general, we're looking at a resonance circuit that amplifies signals based on a resonant frequency to our body. Challenges with MRI coils is they're not really conducive to field-based repairs. OEMs such as GE, Siemens, and Philips, or really any of those guys, do not provide schematics for end users or service engineers. If you wanted to do some investigation, you're going to have to develop schematics as well as test procedures on your own. The OEMs just don't get to that level of granularity on this type of device. Coils as well as ultrasound probes are almost viewed as accessory devices by an OEM, even though they're their own class 2 medical device. You definitely need some specialized tools and test equipment. We develop all of our test fixturing in-house. There's nothing off the shelf other than, say, voltmeters or power supplies or network analyzers that you can consider standard in our repair facility. We design our own test fixtures and what we call emulators that interrogate the coil as if it was connected to a magnet itself. And the last thing is, coils don't lend themselves to troubleshooting. You know, downtime for a magnet is considerable revenue loss. So you're not going to work on a coil on a live magnet whenever there are patients that can be scanned. So they're really not the most cost-effective troubleshooting tool as well. So you're usually looking for some kind of partner to perform coil repair for you, or some kind of aftermarket exchange or an exchange with an OEM. So we're going to look at some failure analysis data, and all of this data is current and up to date. It spans from last 2 Augusts ago to current. We're going to look at 330 different coil models across 3,600 different repairs, and these are customer repairs. If we aggregated all of the repairs to our loaner fleet, we're probably looking at about 5,000 repairs in 2 years' time. Data is relevant to your facility, so if you don't have one of our top 10 coils that we're going to be talking about here, you're going to be able to relate this information, and you'll see that as part of this from our top 10 models that relate to the models that are in your facility. So if we look at failure analysis data, we're going to compare what we call a reason for service, a reported problem is, to what our main findings or contributing findings are. And we'll classify those into 2 different categories in this case: normal wear and tear, normal use, general wear and tear, or preventable damage. And right now we're going to look at just mechanical conditions. So if something comes in with broken screw bosses or standoffs that hold screws in place, you can bet that that's probably preventable damage. Those items typically don't break on their own. If we have physical damage to a hard plastic housing, that normally doesn't occur under normal wear and tear. Any kind of physical damage to a connector housing, any connector damage such as bent pins, we're going to lean towards the preventable damage type of end of the spectrum. But if we look at missing screws or loose hardware or worn out components, stiffened components, or foam that has broken down or worn, we're going to lean more towards the normal use general wear and tear items. Use these color codes throughout this presentation. Gray is for normal use. Preventable damage can be the teal color that you see there. Next, let's look at sort of the electrical analysis that goes along with a coil failure. Again, we go with, did a failure occur under normal use, sort of a random electronic failure, or was it on the other extreme end of the spectrum where it's preventable damage, or is there some gray area in the middle that might be partly normal use or combined with some preventable damage? And that's what's in the middle of these things. If we have an intermittent system cable, it might be wear and tear. It might be aggravated by some trauma. Same with flexible circuits that you saw in the flex coils that you have, or just intermittent wiring. There's sort of a gray area. And that's where putting all of this data into one analysis tool helps us identify, did these failures occur preventatively or as part of normal wear and tear? So what we're going to do here is I'm going to give you a template for the top 10 coils that we have done, as well as the remaining coils in that volume. And we're going to sort of template it like this that you see here. I'm going to put the make and model up in the upper left-hand corner, who made the coil and different part numbers that are there. Just for the sake of conversation, I'm going to show you the repair volume in our last 2 years. And again, this is just customer coils. It's not our own loaner inventory. We'll show them the top 3 most frequent failures that occur on this particular coil model. Down in the lower left-hand corner, you're going to see a breakout of percentage of normal wear and tear versus preventable damage. I'll give you a photo of the coil so you can associate that visual in the upper right-hand corner. And then I'll show you some statistical analysis breakdown of the components that have failed in these coils, whether it was a component failure, a cable failure, wiring, electronic tuning, wiring damage, intermittencies, such as that. So all of this is going to have the same flow to it. And I'm going to go through these rather fast because I don't want to tie us up on specific coil models. I really want to get to the bulk of the presentation, which is strategizing on preventing some of these damages. But by far our most popular coil model to work on is the GE NVA Neurovascular Array that you see here. So 150 repairs. With this coil model, most of the failures are due to intermittent solder connections and physical damage to electronic components. There's also cuts, pulls, or damages to the cables that you see, to the various parts of the coil that you see in that upper right-hand corner. And then we just have random component failures. But 63% of all of this model coils that have come into our facility have arrived so due to preventable damage. So this coil probably weighs about 15 to 20 pounds. If you have an MRI technologist who pulls this coil down off of a storage shelf, if you look at some of those technologists, they might weigh about 100 pounds, 150 pounds. Pulling that coil off of a high shelf, the physics just doesn't work out all the time. Sometimes these coils do take a drop either from a table or from a storage location. And so a lot of these coils do end up having some type of trauma associated with them. You can see the third type of failure here. The gray area in the statistical section is a component failure. So we do end up with a good percentage of these things just having some components that have drifted out of spec or have just failed. But here, by far, component failures due to trauma is the highest failure item that you see there, as well as cable trauma. And then if we move along to the next coil model, similar volume, 150 repairs in the last 2 years, is a flex coil by Siemens here. Highest type of failure that we have seen is intermittent flex traces and wiring. Why, you ask? Possibly. If you look at that coil, the 4 quadrants that you see there in that photograph, each side lobe of that coil has a nice hole there and almost looks like a handle for a suitcase. a lot of these coils are carried and transported by the foam itself. Inlaid underneath that foam are electrical components, electrical traces that can rip and tear and be stressed over repeated carryings or even manipulating the patient while this coil is in place on there. We also have a lot of the hot damage has occurred from bent pins in the connector. People just get in a hurry and plug these connectors in, and the result is maybe they're not seated just right, and you end up bending some of the pins and the connectors. And the third failure is in combination with the top failure there. The intermittent solder connections are a result of the intermittent flex traces and wiring that has occurred with this type of model. And so there's a lot of green on this slide, meaning preventable damage. And that comes with just inherently to flex coils. This is what we see coming into our facility. Almost 70% are a result of preventable damage. So here's another smaller flex coil by GE, and it's a small 4-channel coil. Again, high volume, 130 repairs on this model. By far, the connector encounters the most type of damage here. And I have to speculate, just because it's large and cumbersome, it takes a tumble to the floor a lot of times. And so whether the connector housing is physically damaged or the pins become bent inside the connector themselves just from rushing around, this is where the highest failures occur. And then a lot of the next type of damage is just related to wiring. So it could just be continued flexing, sort of that gray area that occurs, the intermittent wiring. It just could become a lot overly flexed cables, or in combination with a pull or a crush, something like that. And then thirdly, we do have some random component failures. But by far, connector damage far outweighs any type of random component failures or even tuning events that occur from the components inside this coil. So you're seeing a pattern start to develop here. Toshiba Neurovascular Array as well. This is a multi-piece solid coil. So different components. The top component of that coil seats into the bottom section, and it's a modular coil. So there's some detaching and attaching of this coil every time it's used on a patient. So with that comes some damaged interconnects between the various component parts, but we also end up with a lot of intermittent solder connections and just component failures due to trauma. Again, an oddly shaped coil that is cumbersome in nature. It can take a quick tumble to the floor. And also, the third type of failure is just bent, damaged pins in the connector. So by far, component failures due to trauma is the #1 type of failure with this type of probe or the coil. Another type of head coil that we see a lot of is a GE head and neck array. Again, a multi-piece design. So patient lays down, the top part of the coil is then placed on top of the patient's face and head and snapped together to the bottom modular section. With that, we see a lot of damaged interconnects, and I'll talk about why this might occur later on in the presentation. But we do see a lot of physical damage to either interconnects or the connections between the various pieces, and then also the intermittent solder connections. And then thirdly is the just random component failures. Moving on down the list here, we have a flex coil or a shoulder coil by Toshiba. This type of coil expands and contracts as needed, so it's sort of a flexible but yet solid design by Toshiba there. But inside of that hard outer shell are some flexible traces that are continually being manipulated as this coil changes size. With that, we end up with intermittent flex traces and intermittent wiring just from all the movement that goes back and forth. So there's a gray area with this leftmost statistical type of design here. Second to that is just connector trauma. We get a lot of bent pins in the connector. MRI coils have very large, big, bulky connectors, and some of the pinouts inside of these, there are a lot of pins, and they're very fine in nature. So it's easy to bend these things if the connector, it just isn't seated just right when it's being applied to the magnet itself. Another type of flex coil, a larger type of flex design, is 1.5T Express anterior array. So this would be laying on top of the patient as they're laying on the table inside the magnet. Again, with flex coils, we see a lot of intermittent traces. It could be in the flex coil themselves or the trace circuitry themselves that just wear out from just continual flexing. But again, with that comes people carrying, the users carrying these around like suitcases by those, I hate to call them handles, they're not handles, but they sure as heck look like handles on there, where you see the A, B, and C on the coil photograph there. But anytime a coil is transported using one of the flexible sections of the coil, you're inducing stress to the underlying components and flex circuitry that's underneath those, that flexible foam. And you can guess, we do have another flex coil here, and where the highest statistical failure is are intermittent flex traces. Again, it's a gray area. And second to this is connector trauma. So you're seeing a definite pattern develop here. But this is another type of high volume coil that we see, but 77% of the damage can be preventable, considered preventable, looking at this type of, this coil's design coming into our facility. Another type of head coil that we see come in a lot, and again, a multi-piece design. So different pieces and components of this coil mesh together. And so we're seeing physical damage to pins or connectors that interlock between the different components as well as the connector itself. Again, connector damage, component failures due to trauma, and this probably has one of the highest preventable damages coming into our facility. About 82% of the coils coming in arrive as a result of preventable damage. And the same thing is true. This is I think this is our last coil that we're going to go through on our top 10, but still over 60 repairs in the last 18 months or so on this. But we're coming up with a lot of intermittent solder connections and physical damage to electrical components inside of the coil itself. We do end up with this design, there are a fair amount of just component failures that occur just randomly. It could be different analog components just drifting out of tune. And then intermittent wiring. So you might not have one of our top 10 coil models in your facility. Those top 10 coils comprised about half of the coil volume that we have done in the last 2 years. But there are well over 300 other coil models that we have worked on just in the last 18 to 24 months that have comprised about the same volume that our top 10 coil models have consumed. But if we compare the failure analysis data between our top 10 and the remaining 300 different coil models, if we would overlay those, you're going to see a definite pattern occurring. Component failure due to trauma and intermittent wiring. Connector and cable trauma are, the next ones down out of that list. So you see a definite pattern with coil failures, whether you're in the top 10 or you're in the other 300 models. So summarizing all of this data, over 50% of all the coil failures are related to trauma and preventable damage, and really only less than 20% all related to random component failures and electronic tuning. With that, let's go back and look at why coil failures or troubleshooting and coil repairs don't necessarily occur in the field. There's only so much you can do with what you have at your fingertips. And so, like I said, you don't have the schematics or access to the schematics or the specialized test equipment. Knowing all of the information that I shared with you on the last 10 or 12 slides, that knowledge is power, and how you can strategize to reduce your coil failures is going to be revealed in the next half of this presentation. We have 6 strategies to help you minimize not only coil failures, but ultimately out-of-pocket expenses for either replacing coils or repairing them through Innovatus or another partner. So give me a minute while I wet my whistle here. The number one way to minimize failures and costs based on the failure analysis data that we just reviewed is prevention. So for those of you who support MRI, just take a walk through the MRI suite, do some customer service, talk to your end users, observe the surroundings, observe how coils are transported, observe how they're placed on the patients, observe how the coils cables are routed and how the coils are cleaned. We're not looking to point fingers, just in your casual day-to-day interactions in that area, take in some observations and look at the surroundings. Look at how the coil is transported. In general, the coil should be transported by gripping and supporting it from all of the angles of the most heaviest section. That coil that I show there looks like it has a nice handle on top for you to carry this like a suitcase. It is not. It's a very fragile section of the coil. And it'll actually fracture if you try to lift that coil by that nose piece right there. It's always a best practice to transport a coil in any scenario using a cart versus trying to carry it or cradle it. So just look at a coil, see how it's transported in your MRI suite. Flex coils. Flex coils should always be cradled either from the bottom or gripped at that large center solid housing. Some of the coils actually have a sticker and a label on it to remind the users not to pull, not to lift by those flexible sections. Again, underneath that coil section, that foam section, are flexible circuitries. And there are discrete as well as surface mounted components embedded in that foam. And also, it should be known that you don't carry any type of medical device by the cable, let alone MRI coils. If we look at patient placement practices, if you're dealing with a coil that has a multi-piece design like this head coil that I'm showing you there are interconnects between the different components. It's review with the end user. It's best to pull those sections apart straight up and apply those sections together straight down. If you apply those at any kind of angle, you might crack or deform the interconnects between those various components. And again, with flex coils, we're not wanting to adjust the position of the patient while they're laying on the coil. There's a shot of some of the components that are embedded in that flex circuitry, and those things just become torn, the solder connections break, then you end up with intermittent problems or just a hard failure. Cable routing practices. It's a best practice not to loop the cable in a loop. Again, in an MR environment, we're looking at a lot of RF energy, And so any type of looping of the cable, you can end up with almost making your own type of inductor or coil, and you can cause coupling or decoupling issues with the coil itself, and you can degrade your image quality just by the way the cable is routed in the environment. Some of these cables are bulky, and it's best not to try and bend a cable at a really extreme angle, like I show in the lower right hand corner. You can actually break some of the cable sheathings that exist in these large cable assemblies. And it's always a good reminder for an end user to unplug the coil, move it out of the way prior to lowering the table. We get a lot of these coils that come in with crushed, pinched cables, and then we end up having to replace or rebuild the entire cable itself. Cleaning practices, all of this has to do with prevention. I haven't even gotten into the other 5 strategies yet. We're just dealing with prevention, which is really your number one means of defense. Always follow the OEM's recommended guidelines for cleaning these coils. Typically, the chemical composition is a 10% bleach to 90% water, or a 30 to 70% alcohol to water. The wipe systems that I show there, the PDI Sani-Cloths, there are more than 6 or 7 different types of PDI Sani-Cloths out there. Which ones do you choose for your applications? It's not always specified, and usually it's your infection control departments that are dictating what your end users are wiping all of the medical devices down with. They're typically not concerned with how friendly that wipe is to the medical device. They're mainly concerned with efficacy. There are different levels of, say, friendliness to some of these chemical wipe systems. So it's best to choose one that's most friendly, meaning the one that has the least alcohol components in them. Alcohol has a tendency to, if you haven't experienced it, it tends to remove the plasticides that are inside of rubbers and plastics and makes them more brittle over time. It's always a best practice not to spray anything on the coil itself. It's best to spray on a wipe or a cloth and then wipe the coil down with that type of disinfectant. So just some best practices and some do's and don'ts all summarize the prevention section of this presentation. What we want to do is have you guys partner with your end users. They are the ones using these coils day in and day out. In fact, OEMs recommend that users visually inspect every coil prior to every use. Now, does that occur? I can tell you confidently that it does not. Realistically, managers should work with their technologists to have someone in the department look at every coil every week. And we're going to talk about what they should look for in a minute. And every week, the job is done by a different technologist. So we don't want to have the same technologist do it every week. Different people have different levels of quality standards. So by averaging everyone's eyes together, we'll end up with a good baseline or a good idea of what's going on in the department. If they would see any concerns, they would relate those types of concerns to you all, and then you can follow through or follow up on what they see. But you want to have your end users, before they plug the coil in, take a look inside the connector. It might, at my age, I need readers. So it might need someone goes with a set of readers or a magnifying glass and looks at the coils, the connectors inside the pins inside the connector. You can bet if the pin is bent on the connector side, there's a damaged complement to that on the MRI scanner side. And you're going to end up with intermittent connections on almost any coil plugging into that magnet then. So you want to have the connectors slide together with ease. You want to inspect the connectors for bent pins. You want to have your end users, the technologists, look for cracked housings on the solid coils. Now, these are kind of blatant right here. You can actually look inside the coils themselves, but there's probably some electronic damage that has occurred as a result of the trauma that's occurred to these images on the right-hand side. On the left-hand side, I show a flex coil that is starting to tear right here just from continued flexing. Well, again, if we catch the failures at an early stage, the repair and the severity of the repair is going to be a lot less than a coil that's going to need entire refoaming and an invasive repair to the flexible circuits that are underneath there. So if your end users see any of this, this is a trigger for them to let you guys know to get these things addressed ahead of time, almost preventatively. Again, early detection. Here are a couple failures that just didn't occur overnight. This is a coil sheathing or a coil failure that has occurred probably over months of continued flexing. Again, the outer sheathing has been compromised, but if let gone, if that's a word, much further, damage to the individual wires is going to occur, and then all of the wires will have to be replaced as part of a repair. So again, we're talking hundreds of dollars versus thousands of dollars if we address these things whenever we see a tiny tear to the foam or sheathing versus a breaking of the wires in the wiring harnesses themselves. Summarizing all of these last three sections is partnering with your technologists. Best thing, our advice to you all is to get with your technologists and their management team. They have routine meetings, whether it's once a week, once a month. Just ask for 15 minutes of their department meeting, and then educate your users on what we talked about here. Why the coils fail, how they fail, the best practices. Teach them how to visually inspect a coil and when to alert you to a finding. And so that's the fourth stage of the fourth strategy of this 6 stages. And probably the most important is partnering with these end users. Finally, let's use your senses to help do some troubleshooting. Physically manipulate a coil if it's not working. Listen for rattling and internal noise or creaking as you move it around. That'll give you an indication of, is there something loose inside, something cracked or creaking? That will sort of give you an indication, has this coil had some trauma induced to it? Is something broken inside of it? Innovatus is not going to recommend that you perform any kind of internal inspection to your MRI coils, because you can actually induce an additional problem or many additional problems, and it can also require significant time to inspect some of all of the components that are inside there. When you realize that you're going to be looking for broken solder joints, but you can look for broken solder joints. You can perform some continuity tests on wiring and cables in the field if you absolutely feel you must. But to give you an idea of what you might encounter if you choose to undergo this is some broken solder joints. So the photo on the left-hand side there, we're talking about a 1/4 of an inch, an 1/8 of an inch area is what we're looking at, that's just been greatly magnified. And these tabs between the various copper components and traces has become loosened over time. That's the level of broken solder joints you're going to be hunting down visually, or even doing some conductivity testing. And so this does, when you look at the grand scale of a component level troubleshooting of a coil, you're going to be consuming hours and if not days looking for broken solder joints. You might be able to find some physically broken components that have just been jarred from trauma. But you also might find some missing components. Here's a large head coil that in this right-hand section, I've blown that up to the larger left-hand section. You can see C5 is here, C6 is missing because you should have a complementary design on the right-hand side. And so that capacitor is probably rolling around somewhere inside the coil. You might be able to resolder that into place and luckily get back to working again. But again, to sort of summarize, this whole section is, about 50% or more coil failures arrive due to trauma. So it's best to focus your efforts on prevention, early detection, and education, and sort of base your troubleshooting on visual and functional cues, using your senses, eyes and ears. Look for what's rattling, and then let those with the expertise, the experience, as well as the proper testing equipment and the procedures to restore your coil performance. I am open to sharing this data with you all, or if you want specific data on your particular coil models, I'm happy to dig that up and provide that to you all if it's of need, if you think it's of value. My information is here on this slide, and you could reach out as needed, but I would like to open this up for some questions in the last 15 minutes here.
Okay, Ted, thanks so much. Right, we have a few questions here. The first question is, our coils are covered under contract. Do I need to worry about all of this?
That's a great question. That is a solid question, because most coils are covered under a service contract integral to the magnet, sort of like an extended warranty, or anything you buy at Best Buy, they want to sell you that extended warranty or service contract. The challenge with those types of coverages, even through the OEMs, warranties and service contracts typically don't cover failures due to preventable damage. OEMs will typically exchange that coil with you at no charge up front. But whenever they get that coil back in their lab, or they send it to us for repair, and we report that mechanical damage was found, OEMs will typically bill back the customers, and you might not have visibility to that at your level. You'd also be surprised to know that a lot of coils contain what's called a shock sensor. So if we open a coil up, there's a sensor inside that we can tell if the coil has encountered a drop. And if that shock sensor is thrown, that might be flagged as a billable event on a service contract. And typically OEMs based on your relationship with them, they might absorb the cost of one event, but it's not the norm. Most of the facilities that we've worked with have had to pay some kind of out-of-pocket expense for a replacement coil, even though they've had them under a service contract. So you can never go wrong erring on the side of prevention and early detection, and educating your customers to some best practices. But that's a great question, though.
Okay, well, another one that's come in said, you mentioned that cable failures occur a lot. How do you repair them?
So there are several approaches to repairing a system cable on a coil. There are folks that will splice individually broken wires inside of the cable. They'll try to fish a replacement wire up inside of a cable assembly and use or see if there's a spare wire inside of a wiring harness. But as a repair provider for several OEMs, we actually rebuild and repair cables for them. In turn, they sell them to you as a new replacement part. We have all of the raw materials to fully rebuild almost any system cable needed on an MRI coil. We've developed schematics, bills of material, as well as visual and work instructions and fixturing to build these for our OEM partners. And the thing is, we can rebuild the cables for you just like we do them for our OEM partners. We always like to provide like new performance versus just a quick fix and get it back into service. We want our products or our repairs lasting throughout the warranty period and then much longer.
Hey Ted, this is Nathan. I was going to chime in on that too.
Yeah.
In addition to the standard system cables, there are even newer technologies out there, like Philips has fiber optic in their system cables. We also have the capability for that too. We have a whole line for that, and considering that's one of the most common failures at times with the coils, we have the solutions. So
yeah, that's good to know. Yeah, the fiber optic coils are some of the newest designs, and they are no longer a challenge. Any other questions?
Yeah, another one here is, my challenge is that I need a next day solution. How quickly can Innovatus repair a coil?
So when we talk about MRI coil failures or just MRI failures in general, time is money. Anytime that magnet is down, there is lost revenue to a healthcare system and patient access is compromised. But with this, there are several answers. You know, if all of that is needed is a simple electrical repair, we can easily turn a coil repair down in a day or two. Now, if you send me Humpty Dumpty and your coil is in 10 pieces, it's a little different story. With something like that, there are material cure times, adhesives that need to cure. We might have to fabricate a part and even paint in-house. So sometimes, you know, that might be 10 days, you know, but we can perform quick turnaround times for you all if and when they're needed. So, but great question.
Looks like got time for one more question. Can you repair Philips D-Stream and GE air coils?
So the answer is yes. You know, a couple of our latest breakthroughs are through these Philips D-Stream, which I think Nate mentioned that they're the fiber optic coils. So a coil is a coil. When we talk about the electronics that works inside, how they communicate and amplify and communicate to the scanner is what's changing. So the D-Stream coils have these fiber optic modules and fiber optic cables on them, and they are no longer a challenge. And these GE air coils, they're almost like a blanket. They're super flexible. They're a revolutionary, like, new type of design. And, you know, I think they did pose the industry a challenge when they came out for solutions, but we can repair these types of coils for you if you run into those or if you have failures with those. One thing to remember is, you know, even though you might have a failure, a contract covering your coils on your magnet, if you see one of your coils that has physical damage, it might not be the best avenue to replace that via the service contract. You might end up paying out of pocket. That might be an area to explore a coil repair solution through Innovatus. So it's not about working harder, it's about working smarter. So make the most of your coil service contracts and your repair contracts or your repair partners as well. Any other questions come in?
No, it doesn't look like it. So as we're coming up to our hour, Ted, I'll wrap up now. So thank you so much, Ted, for your time today and for a really great and informative presentation. I'd like to encourage everyone to visit today's sponsor to learn more about the products they provide to our industry. So visit innovatusimaging.com. And as promised, the answer to today's trivia question, of course, is Hershey. So congratulations to our winner, Bruce Kishner. A quick reminder, you can obtain your CE certificate by completing the post-webinar survey. The survey will be emailed 1 hour after the completion of today's webinar, and you must complete the survey to receive your 1 CE credit from the ACI. You'll be able to download your certificate directly from the computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. We'll be back next week with another webinar, so visit webinarwednesday.live for more details and complimentary registration. Thank you once again for joining us today. Enjoy the rest of your day, and we will see you next week.
See you guys. Thanks so much.